Hello. It is great to meet you. Thank you for joining us today for this technical interview. To start things off, why don't you introduce yourself and tell me a bit about your journey with Angular so far?
Hi, thank you so much for having me. I am really excited to be here. I recently graduated with my degree in computer science, and during my studies, I became fascinated with front-end development. I started with basic HTML and CSS, but when I discovered Angular, I really loved how it provides a structured framework for building complex applications. Since then, I have spent most of my time building a few academic projects, including a task management app and a small e-commerce prototype, where I focused heavily on learning the Angular ecosystem. While I haven't worked in a professional corporate setting yet, I have spent countless hours in documentation and tutorials, trying to understand not just how to make things work, but how they work under the hood.
That enthusiasm is great to see. Since you are starting your career, I want to gauge your understanding of the fundamentals first. Let's start with the basics of the UI. How do you typically bind data from your component properties to the template in Angular?
Sure, in Angular, we use data binding to keep the component class and the HTML template in sync. The most common way I use to display a property is through interpolation. That is where you wrap the property name in double curly braces. Like double curly braces, variable name, double curly braces. This tells Angular to take the value from the TypeScript class and insert it directly into the HTML as text.
Right. And what if you aren't just displaying text, but you need to change an actual attribute of an HTML element?
For that, I would use property binding. Instead of curly braces, I wrap the property name in square brackets. For example, if I have an image and I want to bind the source URL or a button that needs to be disabled based on a Boolean variable in my component, I would use square brackets. This creates a one-way link, meaning whenever the value changes in the TypeScript code, the view automatically updates to reflect that change.
That is a solid explanation. Now, speaking of the template, let's talk about directives. Could you explain what Angular directives are and the different types you have encountered?
Yes, I think of directives as special markers in the HTML that tell Angular to change the appearance or the behavior of an element. They are essentially custom attributes that allow us to add logic directly to our templates. From what I have learned, there are three main types. First, there are component directives. These are actually the most common because every component we create is technically a directive with a template. They create a whole new UI element.
And the other two?
Then we have structural directives. These are the ones that actually change the layout of the page by adding or removing elements from the DOM. You can usually spot them because they start with an asterisk, like ngIf or ngFor. Finally, there are attribute directives. These change the look or behavior of an existing element without removing it from the DOM. A good example would be ngStyle or ngClass, which allow you to change the CSS of an element dynamically.
You mentioned ngIf. This leads me to a more specific question. In some cases, developers might just check if a value is null inside a template or use a CSS class to hide something. When would you specifically choose to use ng if over just checking for null values or hiding an element?
That is a great question. I would use ng if when I want to completely add or remove an element from the DOM based on a condition. If you just check for null values inside a template or use CSS to hide an element, the element still exists in the DOM. It just might be invisible or empty. Using ngIf is much better for performance, especially when you are dealing with complex components. This is because ngIf actually destroys the component and all of its children entirely when the condition is false. This means they don't take up memory, and their lifecycle hooks don't run until the condition becomes true again, and they are reinserted into the DOM.
Good. Now let's move into the architecture. One of the core strengths of Angular is dependency injection. Could you explain the concept of dependency injection to me as if I were a new developer?
Of course, at its simplest, dependency injection, or DI, is a design pattern where a class doesn't create the objects it needs to function. Instead of the class saying, I need this service, so I will instantiate it using the new keyword, it simply asks for the dependency, and an external source provides it. In Angular, this is handled by the injector. When a component needs a service, it lists that service in its constructor. Angular then looks at the type of the service, finds the correct instance, and injects it into the component. This makes the code much more modular and easier to test, because you can easily swap out a real service for a mock service during testing. It also prevents the need to manually create the same service in 10 different components.
You mentioned services. Just to be clear, for someone who is new, what exactly is a service in Angular?
A service is a special class designed to hold business logic, data, or functions that need to be shared across multiple components. The idea is to keep components lean. Components should really only be responsible for how the page looks and behaves. If you have logic for fetching data from an API, managing user authentication, or calculating complex values, you put that in a service. That way, any component in the app can use that same logic without duplicating the code.
Now let's dive a bit deeper into how DI actually works. Angular has a hierarchical injector system. What are the implications of specifying providers at different levels, like the module level versus the component level?
That is a really interesting part of Angular. Because the DI system is hierarchical, when a component asks for a dependency, Angular first checks the current injector. If it doesn't find it, it moves up to the parent injector, and so on, until it reaches the root. if you specify a provider at the module level or use the provided in root syntax. Angular creates a single instance of that service that is shared across the entire application. We call this a singleton. However, if you specify a provider inside the component's providers array, Angular creates a new instance of that service, specifically for that component and its children. This is useful if you want to encapsulate state for a specific part of the app, or if you want to override a global service with a specialized version for one specific branch of the component tree without affecting the rest of the application.
Perfect. Let's shift gears toward the internal workings of the framework. One of the most confusing parts for beginners is often change detection. Can you explain what change detection is and why it is so important to understand?
Change detection is basically the process Angular uses to make sure the UI stays in sync with the data in the components. Whenever a piece of data changes, Angular needs to figure out which parts of the screen need to be updated. By default, Angular uses a strategy called check always. This means that whenever any event happens, like a button click, a timer going off, or an HTTP response coming back, Angular scans the entire component tree from top to bottom to see if anything has changed. Understanding this is critical because, in a very large application, scanning hundreds of components on every single event can cause the UI to lag or drop frames, which makes the app feel sluggish.
Since you mentioned that the default strategy can be slow for large apps, how do we solve that? I'm specifically thinking about the OnPush strategy. When is it mandatory and how do you implement it correctly?
You would use the OnPush change detection strategy in large-scale applications where you have many components and frequent events, like a mouse movement or a timer, that would otherwise trigger a global check. OnPush tells Angular to skip the change detection check for a component unless one of a few things happens. Either an input property changes, an event originates from inside that component, or we manually trigger the check. To implement this correctly, the most important thing is to treat your data as immutable. You cannot just modify a property inside an object because the reference to the object remains the same, and OnPush won't notice the change. Instead, you have to create a new object reference using something like the spread operator. By replacing the whole object, you notify Angular that the input has actually changed, and it will then trigger the UI update only for that specific component and its children.
That brings up a very important concept, immutability. You just mentioned it in the context of OnPush, but could you expand on the concept of immutability in general when dealing with state management in Angular?
Yes, immutability means that once a piece of data is created, it cannot be changed. Instead of updating a value inside an existing object or pushing a new item into an existing array, you create a brand new copy of the object or array with the updated values. In Angular, this is crucial for both performance and predictability. As I mentioned with OnPush, Angular's change detection is much faster when it only has to check if a reference has changed, rather than doing a deep comparison of every single property inside a large object. Furthermore, when you use immutable patterns, your state changes become predictable and trackable. You know exactly when a state transition happened because you have a new state object, which is the core principle behind professional state management tools like ngRx.
Speaking of state management, let's imagine a scenario. You are building a massive single-page application with dozens of complex views. You have a choice. You can implement state management using a global service with RxJS subjects, or you can use a dedicated library like ngRx or ngXS. What are the trade-offs there?
That is a classic architectural trade-off. Using a global service with subjects is the simplest approach. It is very fast to set up. You don't have to add any external libraries, and the learning curve is quite shallow. It works great for small to medium apps. However, in a massive enterprise app, this approach becomes a nightmare to maintain, because any component can essentially call a method in the service to change the data at any time. It becomes very hard to track where a bug started. You lose that predictability.
And how does a library like ngRx solve that?
ngRx introduces a very strict unidirectional data flow. State can only be changed by dispatching actions. These actions are then handled by reducers, which are pure functions that take the old state and an action to produce a new state. This creates a predictable audit trail. If something goes wrong, you can look at the sequence of actions to see exactly how the app reached that state. It also comes with powerful debugging tools like the Redux dev tools. The downside, of course, is the boilerplate. You have to write actions, reducers, and selectors just to update a single value. This can significantly slow down initial development speed and adds a lot of complexity for the team to learn.
Given that complexity, if you were to structure a state management solution for a large enterprise app from scratch, how would you organize it to keep it manageable?
I would definitely go with a predictable pattern like the one in ngRx, but I would organize it by feature. Instead of one giant state object, I would divide the state into slices based on feature modules. For example, there would be a user slice, a product slice, and an order slice. This keeps the reducers and selectors from becoming too bloated. I would use actions to describe every event that happens in the system, to handle side effects like API calls to backend. I would use an effect layer. This way, the components only dispatch actions and select data. They don't know about the HTTP calls. This separation of concerns makes the application much easier to debug, test, and scale as more developers join the project.
You have mentioned RxJS several times now. Let's talk about specific RxJS tools. What is a behavior subject and how is it different from a regular subject?
A behavior subject is a special type of subject that stores the most recent value emitted to it. The biggest difference is that a regular subject doesn't have a starting value and only sends updates to subscribers who are already listening when the event happens. If a component subscribes to a regular subject after a value was emitted, it misses that value. A behavior subject, however, requires an initial value upon creation, and it immediately emits the current value to any new subscriber. This makes it perfect for things like user preferences or authentication status, no matter when a component is loaded into the DOM. It can subscribe to the behavior subject and immediately know if the user is logged in or what their theme preference is.
Very clear. Now let's get into the more advanced RxJS operators. Can you explain the difference between switch map, merge map, and concat map? And specifically, can you give me a scenario where using the wrong one would cause a race condition?
This is one of the trickiest parts of RxJS. The main difference is how they handle concurrent inner observables. Switch map is the one that cancels. If a new value comes into the outer stream, switch map immediately unsubscribes from the previous inner observable and switches to the new one. Merge map, on the other hand, allows all requests to run concurrently. It doesn't care about order. It just emits the results as they come back. Concat map is the sequential one. It waits for the current inner observable to complete before it even starts the next one.
And the race condition?
A race condition happens most often in search features. Imagine a user is typing in a search box. If you use merge map to call a search API on every keystroke, you might send 3 requests. Because network speed varies, the first request might take longer than the second or third. If the first request finishes last, the UI will display the results for the first letter the user typed, even though the search box now contains the full word. The user sees outdated results. In this case, switch map is the correct choice because it cancels the previous search requests as soon as the user types a new character, ensuring only the latest request updates the UI.
That is a perfect example. Let's talk about the template again. When you are using observables in your templates, why is the async pipe so important?
The async pipe is a lifesaver because it automatically handles the subscription and unsubscription of observables. If I didn't use the async pipe, I would have to manually call subscribe in my TypeScript code. The problem with that is that I would then be responsible for calling unsubscribe in the onDestroy lifecycle hook. If I forget to do that, the subscription stays active even after the component is gone, which leads to memory leaks. The async pipe simplifies everything. It subscribes to the observable, updates the view whenever a new value arrives, and automatically cleans up the subscription when the component is removed from the DOM. It encourages a more declarative style of programming.
Let's talk about performance again. Imagine you have a user input handler that is triggering far too many change detection cycles. How would you technically solve this using RxJS and component logic to throttle or debounce the input?
To solve that, I would move the input handling away from a standard event binding in the HTML. Instead of calling a function like onKeyUp, I would use an RxJS subject to push every keystroke into a stream. Then I would apply the debounce time operator. For example, if I set it to 300 milliseconds, the stream will wait for a period of silence before emitting the latest value.
But wait, even pushing to a subject inside a standard event handler still triggers Angular's change detection. How do you stop that?
That is where ngZone comes in. To truly optimize this, I would wrap the event listener in ngZone, run outside Angular. By doing this, the input stream runs in the background without notifying Angular that something happened. This prevents a change detection cycle from running on every single keystroke. Only when the debounced value finally emits from the RxJS stream would I call ngZone run inside the subscription. This ensures that Angular only runs a single intentional change detection cycle when the final process data is actually ready to be used in the UI.
I'm impressed with your understanding of Zone.js. Actually, let's expand on that. What exactly is Zone.js and how does it actually interact with Angular's change detection cycle?
Zone.js is a library that creates a wrapper around all asynchronous operations in the browser. This includes things like set timeout, set interval, HTTP requests, and user click events. In the context of Angular, it acts like a notification system. Standard JavaScript doesn't have a way to tell a framework, hey, an async task just finished. Please update the UI. Zone.js intercepts these async events. When a task completes, Zone.js notifies Angular that something has happened. This notification triggers Angular's change detection, which then checks the component tree for any updated variables and refreshes the UI to match the current data state.
Let's move over to forms. Angular provides two ways to handle forms: template-driven and reactive. What are reactive forms and how do they improve upon the template-driven approach?
Reactive forms are a model-driven approach. In template-driven forms, most of the logic, like validation and structure, is defined in the HTML template using directives like ngModel. In reactive forms, the entire form structure and its validation are managed in the TypeScript class using form control, form group, and form builder. This is a huge improvement for complex forms because the state of the form is explicitly defined in the code, which makes it much more robust and scalable. It also makes unit testing much easier because you can test the form logic in TypeScript without needing to render the DOM. Plus, Since reactive forms are based on observable streams, you can use RxJS operators to react to value changes in real time with very fine control.
You've mentioned components and services, but what about accessing elements directly? When would you use viewChildren instead of viewChild?
I would use viewChild when I need to access a single, specific element or a single child component in my template. It gives me a direct reference to that one item. I would use viewChildren when there are multiple elements of the same type or multiple elements that share the same template reference variable, and I need to interact with all of them as a group. The key difference is that while viewChild returns one item, viewChildren returns a query list. A query list is like a dynamic array that automatically updates itself if elements are added or removed from the DOM, which is essential when dealing with lists generated by ngFor.
Let's talk about security and routing. Could you describe the role of canActivate guards? And what happens to the user if a guard returns false?
A canActivate guard is like a security checkpoint for the Angular router. It is a piece of logic that runs before a user is allowed to navigate to a specific route. For example, I would use a canActivate guard to check if a user is authenticated before letting them enter a dashboard page. If the guard returns true, the navigation proceeds as normal. If it returns false, the navigation is cancelled. The user stays on their current page. Or more commonly, the guard will trigger a redirect to a login page, preventing the user from ever seeing the protected content.
To wrap things up on the technical side, let's go back to the very beginning. You mentioned the component decorator earlier. What exactly does that decorator do?
The component decorator is what tells Angular that a class is not just a regular TypeScript class, but a building block of the UI. It provides the essential metadata that Angular needs. This includes the selector, which is the custom HTML tag used to place the component on a page, the template, which defines the HTML structure, and the styles, which define the CSS for that component. Without the decorator, Angular wouldn't know how to render the class or where it fits into the application's DOM structure.
You have a very strong grasp of the fundamentals, especially for someone who is just starting out. I appreciate how you connected the theoretical concept to actual performance implications, like with the OnPush Strategy and Zone.js. Before we finish, do you have any questions for me about the role or the team?
I do. I am really curious about the current state of your projects. Are you currently moving towards standalone components and signals? Or are you still primarily using ng modules? I have been reading a lot about the newer versions of Angular, and I am very eager to see how those features are being applied in a professional environment.
That is a great question. We are actually in the middle of a migration to standalone components, and we have started experimenting with signals for state management in our newer modules to reduce our reliance on Zone.js. It is definitely a transition period for us.
That sounds amazing. That is exactly the kind of environment I am looking for, where I can learn the latest standards while contributing to the code base.
Well, it has been a pleasure speaking with you. You have demonstrated a solid foundation and a great appetite for learning. We will be in touch with you soon regarding the next steps.
Thank you so much for your time. I really enjoyed the conversation. Have a great day.